Welcome, welcome, welcome. Thank you for joining us for this month's Bick Gardner Web Seminar. I'm coming to you from lovely Columbia, Maryland, home of Bick Gardner's North American headquarters. And today's topic is visual evaluation of effect colors. Just some opening tasks real quick. Hopefully all of you have managed to connect to the audio at this point. If not, there are two options here. One is to connect through your computer's audio. The other is to call in using one of the numbers appropriate to your location. Of course, if you have not managed to connect yet, then you can't hear me. So we will leave the slide up for just a few seconds, and hopefully everyone will be able to join us. Your speaker today is myself, Corey Cohen. I'm the application specialist with Bick Gardner USA since February 2011, and I specialize in customer education and technical training. Just some general info about today's web seminar. The mute setting has been initiated by me for all of you. That way, mine should be the only voice that you hear, unless, of course, my dog decides to chime in. Please document any questions you may have in the chat function. If I haven't answered your question by the end of the presentation, you can enter it into the chat, and we will have some time for a brief question and answer session. And yes, a PDF version of this presentation will be sent to all attendees following the presentation. So without further ado, effect colors, what do you see and how does it match your color results? So today's agenda includes what are the influencing factors for visual evaluation of effect finishes? How are they defined in international standards? What is used to evaluate lightness, color flop, and sparkle? What are the influencing factors of outdoor evaluation of vehicles? And how can different lighting and viewing angles be simulated? So, visual perception of effect finishes, it's highly angle dependent, both the angle of the illumination as well as the angle of the observer relative to that illumination. So some influencing factors, as mentioned, illumination angle and viewing angle, but also viewing distance, the distance of the observer from the part or the automobile being observed, as well as the lighting conditions. So here we have two standard test methods side by side. We have the VDA 280 Part 8C, which is a method commonly used over in Europe. And then we have the SAE-J 361, which is used here in the US and North America. SAE, by the way, stands for Society of Automotive Engineers. VDA stands for something in German, which I don't currently remember. But you can see some slight differences between these two methods. The illuminance, the SAE calls for a couple extra illuminance, the lux levels. One of the biggest differences here that you'll see if you look at the bottom, the VDA method calls for sparkle evaluation, visual sparkle evaluation, where the SAE method does not. So when viewing effect colors, when viewing surfaces with effect pigments, there are several different ways we look at these surfaces to see different things. One position that we view as is called the face position, and this is where the surface being viewed is pretty much parallel to the observer, or you can say that it's perpendicular to the observer's line of sight, as you see here. And then we have the flop position, where the sample is rotated so that you're viewing it at a very sort of shallow angle. And then we want to also view the travel, which is how much the color is changing as we change viewing angle. And so for this, you're going to sort of rotate through different intermediate angles. So this is a diagram of a viewing table, a sample table, as specified by SAE. These are the actual specifications. You can use this to build an actual table under that test method. And here are just some general recommendations for visual evaluation using a table like this. You want uncluttered, neutral surroundings. You don't want lots of bright colors that are going to distract your eyes from what you're viewing. You want to eliminate ambient light. So you don't want a bunch of light coming in through the windows or anything. You only want the samples being illuminated with the specified light for the method, usually using a luminaire light booth. You want a trained and experienced person, always good. And it's good to have some sort of maintenance program, which might include things like a monthly plot of color, temperature, and illuminance of the light source. You can test your light source using a radiometer to make sure it meets the requirements that you need. A maintenance log with things like lamp replacement and cleaning times, and yearly calibration and certification. So here we see that sample table, an actual picture of that sample table as built to those specifications. And this is a common way of common setup used particularly here in North America. And here you can see the angles of the luminaires overhead. I'm told that the side-by-side luminaires are more commonly used here in the US, whereas in Europe they might only use one luminaire. So when evaluating panels, some things to keep in mind. You want to know where is the specular reflection from the light source and which viewing angle is being used. And so for visual evaluation, illumination and viewing angle are changing depending on the panel position. So the lighting is fixed and the observer is fixed, but you're going to change the position of the panel to get different viewing angles. So for the face position, that's the one where the observer's line of sight is perpendicular to the panel. So you might orient the panel like this. In this case, the illumination would be at 45 degrees, and the viewing angle is also at 45 degrees. So you can see here in this diagram, the illumination is given by that yellow arrow. The specular reflection, which is just the opposite angle from the illumination, is given by that white arrow, and then the viewing angle is given by that blue arrow, which in this case is considered to be 45 degrees. The viewing angles, by the way, are measured off of the specular angle. That's the convention used when viewing effect finishes or when using a multi-angle spectrophotometer measurement. The viewing angles are designated as the angle off of the specular reflection. So here we have the flop angle where the panel is turned so that the observer is viewing it at a very shallow angle. So we see that in this case, the specular angle is that white arrow, and so the viewing angle is much larger. So here the illumination is still at 45 degrees, but the evaluation angle is at 110 degrees where the flop would be evaluated. And then here we have what's called the flash, where you're going to observe the panel at the near specular angle. So you can see that in this case, with the panel in this position, that blue arrow is very close to the specular reflection, and so the viewing angle will be pretty close to about 15 degrees, what we call the near specular angles, and this is where you're going to get typically more reflection at the near specular angles, and so the surface will appear typically lighter, which is why it's called the flash angle. So here we have a nifty tool developed by BASF, specifically a gentleman by the name of Kendall Scott. He developed these cards that can be used to determine the evaluation angle for visual evaluation. The way it works is that there are 3 parts to these cards, and they change color depending on the viewing angle relative to the light source. So if you want to know what your observation angle is, you just place this card on the surface or the automobile being observed, and then based on the color of these 3 parts of this card, you can determine what the viewing angle is. So in this case, in this example on the right, we see that the card is green and then kind of a tannish and then white. So based on this diagram, we can see that the viewing angle here is pretty close to the negative 15-degree angle, one of the near specular angles. Here is another tool for determining evaluation angles. This one is for use only with panels, whereas the previous one you could use it on actual parts in automobiles. This one can only be used for panels, and the reason for that is the way it works. You have to insert the panel into these slots in this ring that you're seeing here, and then you take that ring and you align the 0 mark with the light source. So you line that 0 mark with the light source, and then you can sort of move around it and determine what angle you're viewing that panel at. So for color evaluation, for instrumental color evaluation, which we're seeing a diagram here of the typical setup of a multi-angle color instrument, where the lamp is illuminating the sample at a 45-degree angle. And there are 6 measurement angles or viewing angles ranging from negative 15, what we call the behind the gloss, behind the specular angle, all the way up to the 110. And so when we do visual evaluation, we want to match that setup as closely as possible. And so it's important to understand which of these angles you're actually viewing the surface at. So one possibility for evaluations is to use a lighting room or a light studio. And this is a large room which can be used for add-on parts or entire vehicles. It has fixed 45-degree illumination, and the observer can move throughout the studio in order to achieve the different viewing angles that they want to see. So here we have sort of another view, a diagram of one of these light rooms. So for vertical panels like doors, there's illumination coming from the sides of the room. And for horizontal panels like, say, the hood, there's illumination coming from above. So for each type of surface, you still get that direct 45-degree illumination. And so in each case, the observer can position themselves at different locations around that room in order to be at the desired viewing angle. This is all clearly described in that VDA 280 Part 8C method. Another option is to have a lighting cabinet where the observer's position is fixed and the illumination is fixed, but now the panel is moving through different angles, different viewing angles, and these cabinets can be adjusted according to the height of the observer. So the appearance of effect finishes, it's going to be largely dependent on the illumination conditions. Specifically, under direct illumination, as with a sunny sky, when you have metallic pigments or any sort of sparkly pigment in it, that sunny sky is going to cause that sparkle effect to come out. You're going to see sparkle best under direct illumination conditions. And to observe the sparkle effect in these coatings, we need to reproduce these conditions using direct illumination, of course. So here we have 3 standard illumination angles for sparkle: 15, 45, and 75 degrees. In this case, the sample's position is fixed and the observer's position is fixed. And now it's the angle of illumination that's changing. So whereas with color evaluation, the illumination is always fixed, and either the part or panel or the observer is being moved. In this case, it's the actual angle of illumination that's changing. And so things to look for when evaluating sparkle are the sparkle intensity, which is the intensity of the reflection at an individual spot, so how bright a particular spot is, as well as the sparkle area, which is how much surface area is producing that sparkle effect. And so it's a combination of these 2 things that give us our overall impression of the sparkle in the surface. And just a note here, these illumination angles are used individually, not all at the same time. So you'll observe the surface using the 15-degree illumination, and then that will be turned off, and the 45-degree will be turned on, and then that turned off, and the 75-degree on. So only one at a time, not all together. So for viewing panels with effect pigments in them, we have our Biko Spectra effect light booth, which is a light booth specially made for viewing effect colors. And this does both multi-angle color and sparkle control. And so the way this works, for the color evaluation, it provides daylight illumination, D65 illumination under at a 45-degree angle. And there is a tilt table that the sample is placed on, the panel is placed on, to evaluate color and lightness flop under the 6 standard viewing angles: negative 15, 15, 25, 45, 75, and 110. Just like your multi-angle color instrument, our BIC-MAC instrument measures at these exact same angles. So here's a sort of a diagram, a side view of what this looks like. So you have this apparatus in the middle that the sample is placed on, and the illumination is also built into that tilt table. That way, as you tilt the sample, as you rotate it through different angles, the angle of illumination rotates with the panel. That way, the angle of illumination is always fixed, and it's only the observation angle, the evaluation angle that's changing. And so you can use that sample table, that tilt table, to rotate through all those angles from negative 15 to 110 degrees to see exactly what a multi-angle color instrument would measure. Now for sparkle, we use, of course, direct illumination under those 3 angles mentioned before, the 15, 45, and 75 degrees. Now these LEDs are very bright, which makes it easier to evaluate sparkle, or particularly to evaluate differences in sparkle between 2 panels. But that illumination is also dimmable to give different illumination levels. And so again, we have our Biko Spectra Effect light booth side by side with our BIC-MAC eye instrument for multi-angle color and effect measurement. And again, this light booth is meant to mimic exactly the measurement conditions of the BIC-MAC eye, both in the illumination conditions and the viewing angles. So now we're going to talk a bit about outdoor evaluation of vehicles and some of the factors that influence what we see outdoors. So one of the things that influences how we see or how we evaluate things outdoors, is the influence of the sun position. So the sun is constantly changing position. It rises in the east, peaks at about noon, depending on the time of year, and sets in the west. Hopefully this is not news to any of you. So the ideal time of day to perform evaluations outdoors is when the sun is at its peak, which again is around noon. So generally between about 10 a.m. and 2 p.m. is considered to be the ideal time for doing outdoor evaluations. But that maximum altitude, the peak that sun reaches, depends on things like geographical location, where you are in the world, as well as the season. So here, as an example, we have an observer in Munich, Germany, and on June 21st, the summer solstice, when the sun is highest in the sky, the incident angle on a vertical surface is going to be at about 61 degrees. On September 22nd and March 20th, which is right around the fall and spring equinox, the incident angle on a vertical surface will be about 40 degrees when the sun is at its peak. And on December 21st, the winter solstice, when the sun is lowest in the sky, the peak on that day is going to be about 18 degrees on that vertical surface. So with our BICMAC instrument, it again provides 45-degree illumination on the surface, and we like to mimic that as closely as possible when doing visual evaluations. So if you wanted to achieve a 45-degree illumination angle on a vertical surface in Munich, the day for that, well, there are 2 days of the year that happens, March 29th and September 6th. So here we are in Munich on June 21st when the sun is highest in the sky and the angle of illumination is 61 degrees. So what exactly does that mean for us, the observer? So here you have the illumination angle in yellow, the specular angle in black, and then there is the viewing angle. So remember that the viewing angle is measured off of the specular angle. And so if we look at our diagram, we can see that the evaluation angle in this case is somewhere between about 75 and 110 degrees. So now we're in Munich on December 21st, same observer, same location, same vehicle, but now the sun is much lower in the sky because it's winter. And so both the illumination and the specular angle are going to be much shallower. And so that change in the illumination angle is going to also cause a change in the viewing angle. So in this case, the observer will be viewing that vertical surface at an evaluation angle of about 45 degrees. And then we have our perfect days, our 2 perfect days of the year, March 29th and September 6th, the 2 days when in Munich the illumination angle of the sun at its peak will be at about 45 degrees. And that is also going to change the viewing angle a bit. And so in this case, the evaluation is going to be a bit closer to the 75-degree mark. So in addition to the sun's position changing, the height of the observer and the position of the observer can also affect the viewing angles. So different places around the world, people tend to be different heights. The average height of people in different countries are different. For example, in Germany, the average height of a male is 1.8 meters. In the US, it's 1.75. In Japan, it's 1.65. And of course, men tend to be taller than women. So in each case, the average height of a female is going to be somewhat shorter. So people are all different sizes is, of course, the lesson here. And that's going to affect our viewing angle. So in order to mitigate that, in order for two observers of different heights to achieve the same evaluation angle, what they can do is they can move closer to or further away from the surface being evaluated. So typically, a taller person would need to move further away from the surface, and a shorter person would need to move closer to it. So in addition to those factors, the orientation of the panel being observed is also, of course, going to have an influence on our viewing angle. And some things to think about when evaluating cars. For one thing, cars, they're no longer these boxy things with right angles all over the place. They're very curvy, as you can see here. So they're, it's not just vertical or horizontal anymore. There are a lot of intermediate angles to worry about. So there are strong transitions between horizontal and vertical panels that you need to observe. Distinct feature lines and tight panel fits comes into it. By tight panel fits, we mean the joint, the spaces between where the panels fit together. And the reason that's important is because when you're observing colors, evaluating colors side by side, it's easiest to evaluate them when they're directly next to each other. It's much easier for our eyes to tell small differences in two colors when they're directly side by side. The larger the gap between those two panels or those two colors, and the more difficult it is for us to tell the difference between them. So newer cars tend to have very, very tight panel fits, meaning the gap between these panels is very, very small, much smaller than they used to be. And so that means we're more easily going to be able to tell small color differences. And so it's more crucial than ever that the two adjoining panels match. Another thing to think about is the body versus add-on parts. Of course, we have the body and we have add-on parts that are often fabricated in different locations, painted in different locations by different companies a lot of the time, sometimes even using different paint systems. So it's important that when that comes together, they all match, and not just at one angle, but at all angles. And so you need a stable process to guarantee quality over time. So for evaluation of a curved panel, so now we have the sun illuminating our surface, and it looks like we're looking at about a 45-degree illumination angle relative to this vertical surface. So there's our specular and there's our viewing angle, which in this case is pretty much exactly 75 degrees for this observer. But if the observer moves his eyes up just a little bit to that curved part, now we're not looking at a perfectly vertical surface. We're looking at sort of a more diagonal, somewhere between vertical and horizontal, and that's going to affect the viewing angle. So here we have our illumination, our specular reflection, and that dotted line represents the viewing angle. And so in this case, the evaluation will be at an angle pretty close to about 25 degrees. And then our observer moves his eyes downward just a bit, and the curvature is now going in the other direction, and so that's going to sort of broaden the specular angle. And now we're looking at a viewing angle of between about 75 and 110, pretty close to the 110-degree mark. So just placing, for everything else being equal, just placing your eyes on a slightly different spot on the surface can also affect the viewing angle. So now we have our observer evaluating the hood of a vehicle, so a mostly horizontal surface. In this case, the sun is behind the observer. So the sun is hitting, the illumination from the sun is hitting that hood. There's our specular angle, and our viewing angle is measured off of that. So in this case, it's going to be a pretty broad viewing angle. We're looking at somewhere between the 75 and the 110-degree mark. And then the observer moves his eyes down the hood a little bit. So in this case, the angle of the panel being observed, the part of the car being observed isn't changing. It's only the position relative to the observer that's changing. But that's also going to affect our viewing angles. So there we have our illumination and specular angles, our viewing angles. And so in this case, it's going to be somewhere between 45 and 75 degrees. And now we switch to a scenario where the sun is in front of the observer. So the sun is hitting the panel at approximately the same position, or approximately the same angle, except now the illumination is in front of the observer rather than behind him. So there's the specular angle, and so the viewing angle is going to be at the near specular angle of about 15 degrees. And then if our observer moves his eyes up the hood a little bit, the sun is in the same position, but in this case, just from moving to a different spot, observing a different spot on that hood, we're now looking at the about the negative 15-degree viewing angle. So what does all this mean? Why do we need to observe these parts, these vehicles at different evaluation angles? Why do we care about evaluation angles? Well, it's because two panels or two parts could be a good match at one evaluation angle, but not at another. In this measurement data you see here, we can see that these two panels being compared are a pretty good match at the 25, the 45, the 75 degree viewing angle, even the 110, not too terrible. But if we look at the near specular angles, the 15, the negative 15, particularly, the match is not quite so good. So it's important that we know what the evaluation angles are in order to determine whether it matches at all of them, not just one. So the mounting orientation of the add-on parts is going to have an influence on what we see. Again, as we saw before, the matching point, the part where these two panels fit together, which is the spot that we want to evaluate the color match between two panels, it's often on a part that has a slope. So it's not perfectly horizontal or vertical, but somewhere in between. And so here we have an example. We have an observer viewing these two panels at a particular angle. And this observer is saying, this is a great match. We don't need to do anything. This is perfect. Then we have an observer on the opposite side. This observer is saying it's a bad match and we need to adjust this paint. So what's happening? Why are these two observers seeing different things? Well, of course, it's because their viewing angles are different. So in this case, we have our illumination and our specular angle given in yellow and black, and then that the blue line, the blue arrow gives us our evaluation angle, which for this observer is at about 15 degrees. But for this other observer, who's on sort of the opposite side from the specular angle, it's going to be a much more broad viewing angle, pretty close to at about 110 degrees. So these observers are seeing different things because of their differing viewing angles. And if we were to measure those parts at that point with a multi-angle spectrophotometer, this is the data we might get. So one of those observers is at the 15-degree viewing angle, where numerically the difference is about 0.66, not too large, pretty good match. But that other observer viewing the car at the, viewing that joint at the 110-degree angle is seeing a much larger delta E, a much larger color difference. And so this is why one observer says it's a good match because he's viewing it at the 15-degree angle, and the other says it's not because he's viewing it at 110 degrees. So to summarize, Of course, there are many, many factors that influence our visual evaluation of vehicles, especially outdoors, when things can't be controlled as tightly as when using a light room or a light booth. So some influencing factors are the sun's position, which are influenced by the time of day, the geographical location, and the time of year. The sun tends to be higher in the sky or peaks higher in the sky during the summer and much, much lower during the winter. The observer's position is going to influence our evaluation, both the size of the person and the distance between the person and the vehicle. But again, you can mitigate that difference. If you have two observers of different heights, you can allow them to see at the same evaluation angle by moving closer to or further from the surface being evaluated. And the evaluation zones, the orientation of what you're evaluating is also going to affect your viewing angle. So for vertical panels, evaluation tends to be between about 45 and 110 degrees. For horizontal panels, the evaluation tends to be at the more extreme angles, the near specular angles, 15 and negative 15, or the 110 degrees on the opposite side, depending on whether the illumination is in front of or behind the observer. And the mounting orientation of add-on parts can also affect our evaluation angles. So that concludes our presentation for today. We just want you to know that you don't have to wait for one of our web seminars in order to have your questions answered, which is why you see the contact info here for the Vic Gardner Technical Service Team. Myself, Corey Cohen at the bottom right here in the US, as well as my colleague James Fusco, who is our PPE expert. And then we have our technical service team over in Germany at our headquarters on the left. We'd be happy to answer your questions at any time. We'd love to discuss your application with you. You do not have to wait for one of these events to talk to us. You can do that so at any time. So this was, of course, the last web seminar of 2020. But we will be starting up again in January with our first web seminar on the hardness and flexibility of coatings. Please join us. When the pandemic is not going on, we like to do on-site seminars. If you'd like us to come to you and do an in-person seminar, we can customize our presentation just for you, whatever you want to know about, whatever you're interested in learning. We can provide a presentation for that. We can also bring our instruments so you can touch them, use them, whatever you like. We can do a little song, a little dance, whatever you want. We're very eager to please. We have a new website, byk-instruments.com. Check it out. And we do have some instructional videos available showing our instruments in action. You can check those out at youtube.com/user/BIC-video. Okay, and that's it for the presentation part. We're going to move to the question and answer. So again, if you have any questions about visual evaluation of effect finishes that I have not managed to answer, please enter them into the chat function. And I will answer your question if I feel like it. Yes, we will be providing a copy of the presentation in PDF format. And just FYI, this web seminar is being recorded. So you will be able to view a recording of this presentation for, I believe, the next month or so, and it will be on our website in the same page that you used to sign up to register for the web seminar. Why is there more variation in the DB results? Do you mean you're seeing more variation in the B value than in the L and the A? That's an interesting question. It might be that you're seeing more variation in the B value because daylight is a little bit heavier on the blue wavelengths than anything else. So it might be that if you're looking at light-dark flock where the lightness level is changing, the B value might also be changing. Just a theory. But if you'd like to discuss it more, please contact me directly and we can look into what exactly is going on. I'm not seeing any more questions currently. I will leave this open for just a couple minutes. If you have some questions, please enter it. Someone is asking about temperature variation. So there are two components to this. The temperature could affect the instrument being used, or it could affect the actual color of the surface. Some surfaces are what we call thermochromic, meaning they can change color depending on the temperature. Now, as for the instrument portion of it, I can say that our BIC-MAC-I instrument is very, very temperature stable. We have a patented calibration technique where we actually calibrate when the instruments are being built. They're actually calibrated at different temperature levels in order to ensure very good temperature stabilization. The other part, the thermochromic surfaces, that would depend on what colors you're using. Typically, warm colors, reds and oranges, tend to be a little bit more thermochromic, but it would, of course, depend on the paint system being used. So the angles to use out of the 6 would depend on what type of paint system, what type of pigments you're using. As I understand it, it's pretty common for a lot of companies, I believe, to use like 45, 75, and 110. But with certain pigments, the near specular angles, the 15 and the -15, can become more important. I can only give a general answer there currently, but if you have a specific application that you're wondering about, please contact me directly and we can discuss it. Okay, looks like we have no more questions, so we will go ahead and end a little bit early. That will be my Christmas gift to all of you. So I hope you all have a wonderful holiday. I hope this was beneficial to you. You enjoy any time off that you may have, and have a wonderful new year. Thanks, everybody. Yes, my marketing manager would like me to point out that this is our last Bic Gardner web seminar on our website, but we do have our office hours web seminars coming up on December 7th and December 16th. Those will be on dispersions and color systems.